We'll see if that works. At least it builds. So up here, where we have our axis, we have our case for if it's a mouse. Now, in case that it is a joystick, so our axis definition says that this is a joystick. We want to do something else. And what we want to do is pretty much the same. Which means that it might be a good idea, rather than to do a lot of this stuff every time, we're just going to pull out the motion, and then if the motion is set to something actually other than 0, we'll react to it. The motion is 0 float. So we just pull out the current motion. Because we're no longer defining variables, we can do this a lot easier. So for the joystick case, instead of getting mouse motion, we get gamepad axis based on that control index. So with a little bit of luck, we might actually be able to do something. So if I grab this, I can actually control the view very, very slowly. Now this is because we have a little bit of whether I should use index instead of IDX. Good question. Well, I like the shortening of it to IDX when it's just a variable. I could call it index if I felt like it. Now, you'll notice that the motion here is very slow, and that's because we have some mouse scaling as well. And right now that is just being applied raw to our to the mouse input, or to the input of the camera, and instead we should actually only do that when it's mouse input. So what I'm talking about is that we have this multiplier by 1,000th here to our pitch and yaw. And that's the mouse scaling right now. We don't want that when we're using a joypad, or we want something a lot bigger than that. So what I'm just going to quickly do here is I am going to try and apply these raw, which means mouse is going to be pretty much useful. And I also noticed that we're actually using the wrong axes. I want these to be 3, 2, and 3 for looking around, not 1 and 0. 1 and 0 are supposed to be movement, which we'll get to in a bit. So I'm going to try that. I'm going to refresh here. Now mouse motion is all over the place. So is gamepad motion. I cannot control that in any shape or form. I suspect I'm using the wrong axis. Let's just have a quick look. So yeah, I want to use axis 3 and 4. Otherwise I'm using this axis, which is crap. Okay, so we want to use joystick. Okay, let's get this completely right. So up, down is axis 4, left, right is axis 3. So pitch, axis 4, yaw, axis 3. Now, I haven't defined joystick 4 because I wasn't expecting to use it, because I had forgotten that the buttons or the key presses at the top of an Xbox controller are axes. So 3 and 4. Let's go. switch over and refresh. So yeah, this is completely uncontrollable because there's way too much motion. So we still need a scaling factor. It just needs to be bigger. So what we're going to do is we're going to start with 0.1 here. Recompile that, and we're going to try again. See how that feels. This is actually usable. This is good. Great. So now we need mouse speed, which is usually something that's configurable. So what we're going to do is we're going to add for a raw input, which is where we're going to handle this. We are going to add a floating point scale here. Float mouse speed. And when we initialize our raw input here, we're going to initialize mouse speed to 0.01. And when we get our mouse motion here, we are just going to multiply our mouse speed onto it. There we go. Let's try running that. So now I can look around and move with my mouse as usual. But I can also grab the controller and look around with that instead, which is wonderful. So the next thing we want to do here, or at least that I think we should do, is that we should get motion with the controller as well. So this is where we need to have an axis as well. So right now we have buttons for up or forward, back, left, right. But we also want to have axis for them, which makes it a lot more interesting. Yeah, I can flip the camera upside down if I just keep pressing down on the controller. I can also do that with my mouse I can go all the way around and back the right way again. I can also do it the other way, because I have no bounds on that at all. Because who the hell cares about that? Maybe at some point in the future I'll get a look at not doing that. Anyways, so what we need to do is we actually need to add another. Maybe when I'm doing my improved input system, that might be a good point to implement that. Just maybe. It should be an easy fix. So what we want to do is we want to have another set of axes. One called, we're going to call it forward, backward. And left, right. Like that. We're going to initialize those as well. So forward, backward. The axis is called forward, backward. And we are going to initialize it just to be input, axis, input. So forward, backwards. Okay, I can see I need to switch again. So forward, backwards here is axis 1 and left, right is axis 0. So we've added forward, backward axis here, which is joy 1. And then we have a left-right axis called left, left, right. And it is going to be input axis joystick 0. There we go. Good stuff. Warning, yeah, all the stuff there. So now we need to use that actually. And the way we're going to do this, because right now we're doing a lot of fun stuff here with the motion, is that once we've done all of this, what we're going to check to see is if our motion from our keys in the set direction is still 0. Then what we're going to do is we're going to take the motion in our set direction and set it equal to our forward-backwards axis. And then say, and then if, yeah, what we're going to want to do. Now the thing is, we have this wonderful move thing. What we need to do is we need to test if the result of this was 0. So what we could instead just do is to say if we've moved at all if our motion is no longer just 0, 0, 0, 0. Similarly, we're going to check if our motion in the X is still 0. So we haven't done anything with our controls. Then we are going to look at our left-right axis and see if that tells us anything. So same thing down here, we kill off the move variable. Now this is where we do some fun stuff, because here we have a motion variable which we normalize a little bit. But because we're using analog sticks as well, we might want to allow the player to move less than the maximum. So what we kind of want to do is we want to say if the GLM length of our motion is greater than 1, float, and this is where it might pay off to actually store this, because divisions are, or actually calculating the length is not really that efficient. We want to do it as little as possible. So if our length is greater than 1, which means that our motion is relatively big, we want to divide it through by its length. So the length of our motion vector is at most 1. Is GLM length not what I think it is? Journey. I'm going to need to have a look at that in a moment. So now we no longer need to do this motion or this normalization. We've done that by hand already, and we can add stuff together. Warning, initializer list not be used on. Okay, so if this is a vec4 of zeros, vec4, same thing down here. We actually have motion. So far, so good. So let's see if that means I can move around with the gamepad as well. In fact, it does. Now the only problem with using a gamepad is that I can't do up-down motion, which would be really, really nice to do. So we're going to try and see if we can't get that. So let's start by finding the keys. So I want button 0 for going up and button 1 for going down. So what I'd like to do, in principle, is to just add another, so that space here is also input, and this is where it becomes interesting. Button joy 0. And I'd also like down to be joy 1 button. And that, of course, means that these can no longer just be strings. We need to actually work on that as well. So what I'd like to do here is go over into our button class and do something similar to our axis definition. For axes, we have we're going to have a button definition. Now, button definition can be either on the keyboard, mouse, or joystick. Now, this one's a little bit interesting because if we're dealing with a keyboard, we want a string for it, whereas if it's a mouse or a joystick, we actually want an index, a numeric index. So what we're going to do is we're going to let the index down here be a standard variant of either a standard string or a size t. So we're going to import variant. Good. Then we're going to have, similar to this, we're going to have a lot of joystick definitions here. These are not axis definitions, these are button definitions. But they're all going to be on the joystick. Now, similar to that, we're going to add a couple of keyboard definitions. For example, key W is going to be defined by it's a keyboard, and it is going to be the key W key. Just quickly check whether stuff compiles. Const expression variable cannot have non-literal type. So we can't use our wonderful stuff here. Okay, we're gonna do this the nasty, ugly way, I think. We are gonna do a union of a const char pointer and a size t. This is gonna be name. This is going to be number. And we're going to call that the index. And I generally don't use unions that much because they're nasty, ugly things. So I can't remember how to properly initialize them. Union initialization C++. Okay, so we're basically going for a named style of initialization then. Fair enough. So that initializes the numeric indexes correctly. And for this, what we want to do is we want to say that name equals this. Great. So we have key W here. And for some reason, my copy paste just stopped working, which is always fun. Okay, apparently my editor just did weird stuff on me. So I can, okay, this file works. Can I do stuff in here now? Nope. Okay, I'm just gonna close this file and then we're gonna try and open it again. Okay, I'm just gonna close CLine and start it up again and see if that helps. Okay, and the input header file. Great, now I can do stuff here. So we want keys WASD as well. A, S, and D. Then I want space, which is just called space. And then shift left and shift right, called shift left and shift right. So the initializer up here should no longer take button names but button definitions, and the keys are button definitions as well. And that means we can pull out this using declaration here. Now we need to go over here because we have a lot of these strings in which need to be input, button, key W, and so on down through these. So A and key. Now for space and shift, we're going to paste a little bit differently. We're going to do it like this. There we go. So here our initialization is a button definition. And of course we are now, as with the axes, we're going to want to switch based on what key type this is or control type this is. So what we want to do here is we want to look at our key type, and if it's in the case where it is a button definition keyboard key, what we do is that if that key is pressed, we return true, and then we break and move on. Now we don't just use key, we do key dot index dot name. So if that keyboard button is pressed, we return true, otherwise we move on to the next one. If it's a joystick button, same idea. What we want to do is we want to get gamepad button. but instead of using the name, we're going to use the number, because gamepads are indexed by number, not by a specific name. So that means we also need to go for a raw input here. Where we return a boolean get gamepad button. We're going to run through all the buttons, or all the gamepads. If the state dot, and I have to look at my documentation again. Your digital button, digital button for this index is 1. Then I'm going to return true. This button is pressed on this gamepad, otherwise we move on. If no gamepads have the button pressed, it's not pressed, we return false. Now we need to declare that we have this function as well. So this is a bool get gamepad button. So run that. Yeah, we're not handling the mouse right now. No viable conversion from, yeah, I've left this in. Shouldn't have done that. Need to get rid of it. And there's an extra I in button right now, which is a mistake. Try that again. Great. So with any luck, should be able to move up and down with the gamepad as well. That seems to be working.